Welcome to our tutorial on Google Cloud's Compute Engine. In this session, we'll dive into creating virtual machines using the Compute Engine API. Our journey starts with setting up a web server, a practical way to bringing a web page to life. We'll explore a few ways we can deploy virtual machines, and doing so, we'll gain insights into essential cloud computing concepts. Let's get started. In this lesson, we have a few prerequisites. First, ensure you have a Google identity, like one you use for Gmail or YouTube. Second, you should have already signed into the Google Cloud platform at least once and set up your initial default project. Please make sure these steps are completed before we proceed. Having met the prerequisites, our first task is to navigate to the API for Compute Engine. It's found within the Google Cloud console. We start by opening the console in our browser. If it's your first time using a managed service like Compute Engine, you'll need to enable it. Within the console, search for Compute Engine, and then click Enable. Next, click on the Create Instance option. For the purposes of this tutorial, we will be using the smallest instance called Micro E2, and we will be specifying the Iowa region as our default. We'll be going with most of the default options. However, observe the disk configuration settings and note how we can pick from a wide range of different operating system selections. Some premium operating system choices will add additional costs, while others, like our default option, do not. Having explored the operating system options, we'll go ahead and create the instance. At this point, the resource is being provisioned within the Google Cloud environment. Provisioning and deprovisioning of Compute Engine resources can take a few minutes. Once the VM is provisioned, the status will indicate it's ready. The device will have an internal and external IP address associated with it. And, importantly, SSH allows us to connect to the device using the Google Cloud console. Once the security keys have transferred to the virtual machine, we can interact with the machine through a command line console. In part 2 of our tutorial, we'll show you how easy it is to install a web server and offer up a web page to the world. In order to accomplish this, we will be interacting with the command line. The commands we're using are listed here. The first command switches us to root. The second command updates the software packages on the server. And finally, the third command installs the Apache web server. Here, we are entering the commands. First, we switch to root using the sudo command in Linux. Then we update our software and install the web server. Once the packages are installed, we're just about ready to test our web server. However, it's necessary for us to modify one of the settings on our virtual machine instance. In order to allow the web server to communicate with the internet, we need to allow the traffic to traverse our network firewall. To allow this to occur, we'll edit our machine instance, and under the firewall settings, we'll check the Allow HTTP traffic option. This setting is necessary for a successful test. Once the setting is saved, click on VM Instances on the left to quickly return to our machine list. Next, we will test our web server by browsing to the external IP address of the VM instance. Use the icon beside the external IP address in the console to copy the address, then paste the address into a browser window, and you should see the default web page for our web server. Great work! So far, we have created our first Micro E2 VM with a functioning web page. And after enabling the firewall with the modification to allow HTTP external traffic, we're able to see the web page. Here's the command we'll use in the next step. It will be explained in just a moment. In this next step of our tutorial, we'll harness the power of a Linux command known as sed. We'll use this command to alter the content of our default web page. Once you run the command, simply refresh your web page to see the changes take effect. You're encouraged to explore and experiment. Try replacing the text with something of your own choosing. In our upcoming tutorials, we'll explore various methods of deploying virtual machine instances. Next, we delve into how to utilize the Google Cloud Console's settings to automate server commands. We'll achieve this through a powerful tool known as a startup script. This approach simplifies and streamlines the steps that we've previously manually executed. For this next example, we're going to be using those same 4 commands again. Have them nearby and get ready to copy and paste the lines. Using Google Cloud Platform, there are a number of ways to create virtual machines. We'll once again create a Micro E2 instance in Iowa, and this time we'll be sure to specify the proper firewall settings. This time we'll accomplish this by specifying a startup script under the Advanced Creation settings. The contents of our startup script will be the commands that we used in the previous steps. The startup script option is found under the Advanced Management options in the section labeled Automation. When we create a virtual machine with a specified startup script, the script's commands are executed as soon as the machine is created. In this example, we've created a virtual machine with a functioning web server. We've even edited the default web page, and we've accomplished this without having to connect to the virtual machine. This approach saves a great deal of time when deploying instances at scale. While startup scripts save steps, processing them requires an initialization period. If there are a lot of customizations, this can take time. Instead of startup scripts, we can further refine the creation and customization of virtual machines with something known as an instance template. An instance template helps us to quickly provision customized machines with all of the customizations and updates we require, ready to go at startup. Instance templates accomplish this by utilizing something known as a disk image. A disk image is a special copy of a virtual hard disk's contents that can be used to make future copies of our customized instances. We can set up a virtual machine with our desired configuration, create a disk image from this setup, and then use this image to effortlessly spin up future machines with identical customizations. This process ensures consistency and efficiency in deploying multiple virtual machines. To create a virtual machine using an instance template requires a few steps. First, we configure a VM with settings we like. We've already done this, so we will stop the VM we've built and use that VM as our source to create our disk image. We'll click on the Images option, then Create Image. We'll call it My First Image, and for the image source, we'll choose the disk of the VM instance we previously created. It means the customizations we made will be maintained in the image. With the disk image created, we're ready to move on to the next step. In the left-hand menu, click on Instance Templates, then Create Instance Template. The instance template looks very similar to the options available when we create a virtual machine. Give our template a name, and then once again select a micro E2 instance. Next, we'll change the boot disk options and selecting the Custom Images tab. We point the boot disk to the newly created image, which will tell the instance template to use our customized image when creating new virtual machine instances. Lastly, we'll configure the same HTTP firewall setting that we've executed in previous steps. This will allow us to once again test our web server. With the settings from the last step saved, the next step is to create a virtual machine using the template. To do this, click on the instance template in the list, then create VM from the options available. While the template we've created is a global resource, the virtual machines it creates are bound to a specific zone. Once again, pick Iowa and notice how the rest of the options we prefer are enabled by default. With the VM up and running, simply click on the hyperlink of the external IP address. Notice how the web server is up and running, hosting our default page, and the page contains the edited title. While it took us a few steps to set up the instance template, once it's configured, it can be used to quickly create customized instances that are ready to go with the necessary software and configurations. Using instance templates can save time by ensuring customizations are ready to go as soon as the resource is provisioned. These templates also are a powerful enabler of automation. Instant templates can be used to create entire groups of servers, all with the same configuration. This form of automation is a powerful enabler of systems that automatically scale. Now that we've created an instance template, let's put it to practical use. We use instance templates to create groups of servers, called instance groups. When we use an instance template to create the virtual machines within an instance group, we refer to that group as a managed instance group. A managed instance group is a cornerstone of efficiency within the Google Cloud Platform. Within a MIG, each virtual machine is an identical clone, providing a consistent and scalable environment. These groups are designed to maintain a specific number of running instances at all times, ensuring availability and reliability. Coupled with health checks, another key feature of GCP, we can set our instances to automatically recover from issues, enhancing their resilience and uptime. Let's explore managed instance groups. We'll start by navigating to the Instance Group option within Compute Engine. Then, we'll choose to create an instance group. For the name, we'll call it My Instance Group. Notice that the instance template is one of the options used for setting up the group. Choose the instance template we created in the previous step. For the purposes of this demonstration, we'll once again pick a default zone within the Iowa region. Under the Autoscaling options, we'll set the minimum number of instances to be 2 and the maximum to 3. It means that the managed instance group will always ensure at least 2 healthy instances are running at any given time. For the purposes of our lab, we're going to lower the initialization period setting. This time period represents how long it takes for your app to initialize from boot time until it is ready to serve. Next, we need to set up the health check that our managed instance group will use for auto-healing. Health checks monitor crucial metrics to determine the instance status. Since we've installed a web server, a reliable indicator of health would be the server's ability to respond to incoming traffic as expected. We'll create a health check, and we'll call it My Health Check. The default should read protocol TCP and port 80. Also, pay attention to the interval settings. The check interval determines the frequency of the health checks, while timeout defines how long to wait for a response before it's marked as a failure. In our settings, health checks are performed every 5 seconds, and a response is expected within that same 5-second window. Otherwise, it's considered a failure. The final components of the health check we need to consider are the thresholds for determining whether an instance is healthy or unhealthy. By default, these thresholds are set to equal values, but we have the flexibility to define the number of consecutive successful checks to establish health and failed checks to determine an unhealthy state. Having explored health checks, click Save and it will return us, so we can complete our managed instance group configuration. Notice our new health check is specified. For the purposes of our lab, we're going to adjust the initial delay to 60 seconds, keeping the rest of the default settings. Click on the Create option, and the group creation will start. Note that this can take a few minutes, and the presentation video has been sped up in sections. The group will be created, and then it will detect 0 instances are active. This will trigger the service to spin up the minimum number we specified, which is 2. After a bit of time, we can observe 2 identical instances have been created, and both are active. We confirm that the instances we've created are based on our instance template by browsing to the default web page and observing our familiar edited web page. For the next step, we will execute another Linux command to simulate a failure on one of our key services. We'll observe the managed instance group's auto-healing feature at work. The command we will be executing is listed on the screen. Once again, we will establish a session with one of our virtual machines. Once the console session is open, execute the command to stop the web service. This intentional act will cause health checks to fail, allowing us to observe what happens next. Notice that after we refresh the web page, we're down to 50% health on the instance group. But waiting just a few moments, we see that the status returns to green as the defective virtual machine is automatically replaced with a healthy one. It's very important to clean up our resources at the end of our practice sessions. Delete the managed instance group the image and the instance template. Managed instance groups support both the concept of auto-scaling and auto-healing. Auto-healing works with something called a health check. When a VM fails a health check, a new VM is automatically provisioned to replace the ailing instance. Auto-scaling, on the other hand, allows our environments to scale based on demand. Before we can use any service in Google, the API must be enabled. By default, most are disabled, requiring us to enable them the first time we use them. Ensure the Compute Engine API is enabled before proceeding. When doing a lab, it's very important to remove the resources and objects created during the exercise. Leaving unused resources lingering during the free trial will consume trial credits. Consuming resources after the trial incurs costs. Be sure to delete the instances, instance template and images we've created. In conclusion, this tutorial on Google Cloud's Compute Engine has created virtual machines using a few different techniques. We began with the essentials of setting up a web server on a micro instance in the Iowa region, navigating through the Google Cloud console to create and configure our instance. We explored various aspects of instance deployment, including choosing operating systems, understanding disk configurations, and provisioning resources within the Google Cloud environment. Key operations like SSH connectivity, software updates, and web server installation were demonstrated. We looked at editing firewall settings to enable HTTP traffic, which is necessary for an internet website. The tutorial also introduced Linux commands for customizing the web server, illustrating the flexibility and control available in Compute Engine. Advanced topics such as automation through startups, scripts, and instance templates were covered. These tools simplify the deployment process and ensure consistency across multiple VMs, showcasing Compute Engine's capabilities for scalable and efficient cloud infrastructure management. We discussed how we can restrict who can access the virtual machines with identity and access management. The same IAM framework also can be used to control what type of access our virtual machine has to other resources within the Google Cloud ecosystem. We delved into the creation and utilization of managed instance groups, highlighting features like auto-scaling and auto-healing. These concepts underscore the platform's resilience and responsiveness to varying demands, ensuring high availability and efficient resource utilization. Together, instance templates and instance groups are fundamental to automating deployments in Google Cloud. They streamline the process of setting up and managing virtual machines at scale. Instance templates act as blueprints, ensuring that every machine in a group is configured identically, from the operating system to the installed applications. Meanwhile, instance groups manage these machines collectively, offering powerful features like load balancing and auto-scaling. This combination not only simplifies the deployment process, but also enhances the reliability and efficiency of cloud infrastructure, making it easier to maintain and scale applications as needed. Click on the Create option, and the group creation will start. Note that this can take a few minutes, and the presentation video has been sped up in sections. The group will be created, and then it will detect 0 instances are active. This will trigger the service to spin up the minimum number we specified, which is 2. After a bit of time, we can observe 2 identical instances have been created, and both are active. We confirm that the instances we've created are based on our instance template by browsing to the default web page and observing our familiar edited web page. Instance templates in Google Cloud can be utilized to create instance groups, which are collections of virtual machines. By forming instance groups from a template, we ensure uniformity in our deployments. This uniformity contributes to creating robust systems. Such systems are capable of auto-healing, as they can automatically spool up new instances whenever needed.